So, welcome back. So, in previous lecture we discussed mostly about the terminologies, and as I told that to some extent it is important for us to understand the or know about the geological time scale. We discussed about the era, period, epoch, and the most important epoch for particularly our studies of paleoseismology and active fault is your quaternary period. So, in quaternary period, which we have the epoch, Pleistocene and Holocene, and as I told that if you take in terms of the years, how many years back we should go in terms of the geological time, then 10,000 years is quite good enough to understand the seismicity pattern and all that in particular region. Of course, you can go further below that, that is your into the tertiary part also, but as we were talking about that if you are within the quaternary period, then the fault activity has been termed as active fault. If you are within 10,000 years and beyond that up to say 1.6 or maybe 1.8 million years, then you are talking about the potential active fault, and further down is inactive. Now, this inactive, how far this is considerable, we will discuss this when we are coming to the individual topics. That what we have identified that some of the potential faults which might not have shown the activity in last 5,000 years have become active in present day. Okay. So, moving further in this part, this is the same, but this is more detail about all the geological time scale, era, period and epoch we are having here. So, for us this is the important one, that is if you are talking about either 1.6 or 1.8. So, in some literature you will find this as an 2 million years, in some literature you will find as 1.8, and the most youngest one, that is the most youngest epoch, is your 10,000 years, that is your Holocene. So, basically what we are going to look at is the youngest or the most youngest landforms and the sediment succession to identify the signatures of the earthquakes. Now, coming down to the paleoseismology part, if you look at, then we have the paleoseismology basically is a part of the geology or earth sciences. So, as a definition, if you take paleoseismology is a branch of geology where we study prehistoric earthquakes, or we can say ancient earthquakes or old earthquakes that have not been recorded by instrument or those occurred during last 10,000 years. So, not been recorded by instruments, because this is again we are talking about the before the invention of the instruments which started recording the earthquakes, mainly the seismic meters and all that, and further more older, if you want, you can go up to 10,000 years. So, this branch of geology, that is paleoseismology, supplements historical and instrumental records of seismicity by characterizing and dating large prehistoric earthquakes. So, if all the data is available in the historical chronicles, or they were been also recorded by the instruments, so basically it tries to complement and it helps in characterizing the events. Okay. So, dating part is what you are talking about, that if you have the ages, we can bracket the events, and we can at least be able to tell that when those earthquakes took place on a particular fault. So, and as I have been emphasizing right from the beginning, that we are interested in the large earthquakes. So, if you refer one of the slide of the previous lecture where we have discussed about the rupture areas or the rupture length, then up to 5 magnitude, no evidence you will be able to see, but above 5 magnitude earthquakes you will be able to look at, or there may be a displacement and which varies. Okay. For example, 9.5 magnitude, the rupture may extend up to 1000 kilometers. So, mostly we are concerned about the large magnitude because a large amount of energy will be released, and they would be more damaging in terms of the hazard. So, significance, briefly I just told about that we need to have the complete database of the earthquakes which were recorded by the instrument or which were unrecorded by the instrument, and which the data is available in the historical chronicles, or maybe they have been missed out because of some or the other reason. Okay. So, significance of paleoseismology is basically, it mainly deals with the study of deformation of landforms and sediments. And again we will say that okay, fine, the sediments which are, or the landforms which are about as old as 10,000 years. So, up to 10,000 years will be more keen, and so those landforms and the sediments deformed under stresses during earthquake. The knowledge of when, where and how big and how often large earthquake occurs is crucial for evaluation the seismic hazard of any given region. So, this is one of the basic we can say the motto of these studies, that basically we want to know that when, where, how big was the earthquake and how often such large magnitude damaging earthquakes. Okay. Earthquakes have occurred, and this will eventually help in evaluating the seismic hazard of any given region. So, basically we are interested in seismic hazard assessment. So, this data forms a very crucial parameter for the hazard assessment. Further, it seeks to decipher the history of large earthquakes along individual or a particular fault and throughout a region over 100 to tens of thousands of years. So, we are trying to reconstruct the history of large earthquakes, and that also on individual faults. So, we are not talking about the regions. In particular region you may have number of faults. Okay. So, number of active faults, those different faults will have different history of large earthquake. So, this is again, for example, if you are having several fault lines. So, when this fault A, B and C got activated and were responsible for triggering earthquakes. Okay. So, they will probably not show the same time span of the occurrence of earthquake. So, suppose this earthquake has hosted an event in 1900 AD, this might have hosted an event in 1400 AD or so. Okay. So, the time is different, and when basically we are talking about the recurrence, how often. Okay. So, this is the part of the recurrence we are talking about. So, when you know the characteristic of the individual faults, then you will be able to have better seismic hazard evaluation. And further, for earthquakes, the past several thousand years to several thousand years, paleoseismic studies complement historical and instrumental data. So, as I told in this one of the point here on the top, that we can complement the data which has been generated from the paleoseismic study with the data which is available from historical and instrumental records. So, that also can help in a sense, because during the historical times or even before, if particularly if we talk about the Indian subcontinent part or any other region in the world, the paleoseismology is not very old science of that is the field of earth sciences, because it has recently been evolved, not around 1980s or so. So, characterizing the individual fault and correlating those events with the historical data is going to be an extremely helpful part. Okay. Now, paleoseismology is also a part of broader fields of earthquake geology, which includes aspect of modern instrumental studies of earthquake, that is seismology, tectonics and structural geology, historical surface deformation, geodesy, that what I was talking in the previous lecture, that even the geodesy can be taken into consideration, and the deformation pattern of the historical time can be compared with the ongoing present deformation with the help of GPS. Then it also deals with the tectonic geomorphology, the geomorphology of tectonic landscape. So, there are broader fields which are also included. So, you need to have the understanding of the structural geology in the sense here, okay, and then the tectonic geomorphology part. So, these are two important portions or the fields which are important, and along with this we also need to have the understanding of sedimentology part also, because we will be dealing with landforms and sediment succession. So, this two needs to be understood well. So, there are few more references, or maybe you can say the definition by different groups, which talks about the comparison of definition for paleoseismology and related fields. Okay. So, paleoseismology can be spelled either like this, PALEO, or you can say PALEO. Okay. So, there is this may be in other like British spelling is something where we have additional A here, but both are correct. Okay, no issue for that. So, it says that the study of prehistoric earthquakes especially talks about their location, timing and size, and this definition is from the book of Paleoseismology by McAlpin. And then second one, it talks about the study of timing, location and size of prehistoric earthquakes. Paleoseismology differs from other aspects of earthquake geology in its focuses on the almost instantaneous deformation of the landform and the sediments during individual earthquake. So, the paleoseismology mainly focuses on the landforms and sediments, okay, and where the area has gone under instantaneous deformation because of the individual or respective earthquakes. Okay. Further definition is that it is the subdiscipline of geology that employs features of geological records to deduce fault displacement and age of individual prehistoric earthquakes. So, here this talks about again almost similar, that it talks about the individual age. Okay. So, when you say age, then you are talking about the timing of that particular event. Then another definition has been given: the geological investigation of individual earthquake deduced or decades, okay, the earthquake decades, centuries or millennium after their occurrence. Okay. So, whatever the signatures are preserved in geological records. So, geological records, if we say in the is a broader sense, but if we narrow down, then we are talking about the landforms and the sediments. Okay. So, those earthquakes which have occurred either 100 years ago or 1000 years ago or more. Okay. Further, the study of ground effect from past earthquake as preserved in the geologic or geomorphic records. So, ground effects will be all related to your landforms. Or you can say also, as I discussed very briefly, but we will talk later, that is the liquefaction. So, mainly this will include your fault scarps and displacement of the landforms, that is the manifestation of the ongoing deformation on the surface, and you talk about the geologic sense, then you are talking about again the landforms and the sediments. The historical paleoseismology, the definition is that it helps establishment of lengths of displacement and displacement of ruptures on a specific fault due to historical earthquakes. Okay. And this has been given by Bob Eads, 1994. So, there are several definitions for paleoseismology and related field. So, in short, what we can say that the studies will include, maybe in the next coming slides you will find those bullets. Mainly we are focusing on landforms and sediment record. And we are interested in knowing the timing, location and size. Size will be your magnitude, because this whole exercise is going to help us in terms of the reducing the hazard related to a particular earthquake, or you can say the earthquake triggered or occurrence of earthquake on a particular fault. So, these are a few examples of the different type of different definitions and comparison. Okay. Then further, paleoseismicity, prehistoric earthquake resulting in slip on faults. Then we have earthquake geology, neotectonics, active tectonics, morphotectonics, seismotectonic. So, earthquake geology in the broad sense, the study of the history, effect and mechanism of earthquakes within the earth crust. So, I will not go into the detail of each and every part here, but you can read out when you are having the notes. But of course, the important portion here is that neotectonism, then talking about the active tectonism. So, the neotectonics, the study of post Miocene. Okay. So, this you are talking about the tertiary period. Okay. So, tertiary period, the age, or you can say the transition of tertiary and quaternary. So, during the transition of this two period, whatever the studies or the structures we are talking about is been termed as the neotectonic activity, active tectonic movements that are expected to occur within a future time span of concern to the society. So, this is the most important one for us. Okay. So, the future time span of, and it is concern to the society. So, this is most important for us in terms of doing when we are talking about the paleoseismology part. Morphotectonic, again the tectonic geomorphology is the similarly you can take, because morphology of the surface. Okay. We are talking about the morphology of the surface, and those surfaces or the landforms which are generated because of the tectonic activity. So, morphotectonic basically confines to the tectonic geomorphology. Okay. Seismotectonic, study of the role of seismic activity in tectonics. Okay. So, then you talk about mostly the earthquake pattern and all that, and in terms of that you also talk about the occurrence of the earthquakes, either micro earthquakes we are talking about, small earthquakes, and based on that if you do the detailed investigations, then you may pick up the precursory events. Okay. So, this portion of seismotectonic is the part where the seismologists are more involved, and they look the distribution of the seismic events or the earthquakes on a regional scale, and whether they are telling something about their relevance with the geological structures, and this geological structures could be your active faults also. Okay. So, basically we have a couple of definitions which we have seen here, which are in connection with the paleoseismology part. Okay. Then further, this is what we were talking about, the morphotectonic is the tectonic geomorphology, the tectonic interpretation of morphological or topographical features of the earth's surface. It deals with their tectonic and structural relations and origin. So, those landforms which have been formed or generated by the ongoing tectonic activity. So, on the larger scale, if you take, you can talk about the orogeny, okay, and that is your Himalayan orogeny. So, on the global scale, okay, local scale and the regional and the local scale, you can talk about the folds, faults, and further what we are talking on the local scale, what we do for the paleoseismological part. Okay. So, in a nutshell, the paleoseismology helps in understanding neotectonic activity, and that what I was talking about, the tectonic activity, that is neotectonic activity is the movements that took place during late Cenozoic, that is during the transition of tertiary and quaternary period. That is been termed as, that activity has been termed as or defined as the neotectonic activities. Further, it helps in knowing the regional pattern of tectonics and the behavior of individual fault. It directly helps society by giving needful information about the natural hazard, and here the natural hazard, what we are looking at, geological hazard, is your earthquakes, and it helps in giving the idea about that probability or the severity of the future earthquake in a given area. So, as I told that this field is quite young in the sense, okay, of and not many regions have been explored, and even in terms of the Indian subcontinent, we know that there are 3 major seismic zones or the vulnerable zones or the regions. One is Himalaya, Andaman in the east, and west is Makran zone, and Kutch we are having in the west. So, this field was started like before in 1980, the assessment of the earthquake hazard in United States and USSR was based solely on the historical earthquake records. So, as I have been emphasizing that the one most important part on which the study should be started, that the paleoseismic studies, is the historical record, if at all we have that historical record. But if we are not having, then that will help us in reconstructing the past events. So, we mostly the paleoseismology was initially they were when initiated in the countries like US, Japan, and then slowly we are now also have like in last 2-3 decades we have started in India. So, before even 1980 in the countries like US and USSR, the hazard assessment was been done based on the historical data. So, for a country like us, suppose we are not having the if we have the historical records, then at least we will be able to do the proper assessment. But to some extent, if we are not having, for example, the historical data is not available, then it is difficult and we may undersize the overall hazard. But now most workers investigate seismically active faults. To understand paleoseismic study or to undertake the paleoseismic study in both regional and site specific seismic hazard assessment. So, for example, for the Indian part, we even do not have the complete active fault atlas, and of course, we are lacking in the historical data also. We do not have enough historical records to have the proper assessment. So, for us, the paleoseismic studies, either we are talking about on the regional scale or on the site specific, is extremely important. In most of the seismically active regions of the world, including Himalayan belt, many active fault zones have no historical records for large magnitude earthquakes, and further the paleoseismic studies is one of the common practice. So, in countries like United States, Japan, New Zealand, this is one of the common practice, but in India this was not a common practice, and still I would say that very few groups, research groups in India are doing this type of studies, which is extremely important for the reduction of the life loss as well as property. Now, these studies have provided significant data towards recognition of individual paleoseismic events on a particular given faults, behavior of individual active fault segments, rate of faulting, slip rate along the fault, reconstructing the history of large magnitude earthquakes and their repeat time, etc. So, that is we are talking about the recurrence interval. Then seismic hazard assessment of any region will be more easier. So, these are few points which are important for this course, which you should remember. So, I will stop here and we will continue in the next lecture.